So for 3.7 linear inequalities in one variable, we're talking about kind of just how to deal with inequalities, obviously the inequality signs, less than, greater than, and especially a focus is going to be on the notation, how to express an answer in using, what is it called, set builder notation, or it's sometimes just called set notation, or the other one's called interval notation. Both are not too difficult. The first part of your notes here, you guys can just pause the video and just copy this down. Just all hopefully you guys get the general names there of the inequalities. And these properties right here, we'll just go ahead and address those when we run across them. Okay. So when it comes to graphing your solution, what you're going to want to do is, there's a couple different ways you can graph it on a number line. I'm just going to do just a real basic number line here. And one way is to put the point itself, let's say we're graphing x is less than 4 or something. You can put the point itself right on the number line like that. You can put it on there. And then you're going to draw a vector, also known as an arrow or shaded in. You're going to draw your vector going in the direction that the inequality is telling you to go to. All right, so for that one, that would be greater than. And if the vector's going left, then that would be less than. All right. There's also a couple different types of points. We could use I just showed you. We could use a closed point, or an open point, and a closed point. This is right here is an open point, and I'll address how to know what kind of point to use, whether it's an open or closed. The set notation is going to look like this, where we use these symbols right here, and depends on the variable used in the problem. But let's say x is typically used, something like that. And then you're going to have this symbol, and then you're going to have the inequality. So I'm just making up an example here, like less than or equal to, like -10. And the way that it's stated is that symbol right there, that little tall vertical line. What that represents is that, I know this is kind of weird, but that's represents such as. So when we kind of express that particular inequality in set notation, we're going to say that x is all numbers. X is all numbers such as, or such that, x is less than or equal to -10. That's it. I should say not such as, but such that is probably a better way to put it. Interval notation can be tricky, and we're going to get to this, but interval notation, sometimes we use brackets, and then parentheses are going to be used for other things too. But interval notation, you can have an answer that looks like this, like you can have like 8 and then positive infinity, something like that, which represents x is all numbers such that it's greater than or equal to 8. So the bracket represents greater than or equal to. And whenever you have infinity, you want to bound it with parentheses, okay? You want to use parentheses always, whether it's negative infinity or in this case it's positive infinity. You're going to want to use parentheses always. You're going to want to bound your, you want to close up your infinity symbol with parentheses, never a bracket. Okay, now that's just, like I said, that's just one example, and I'll show you. I think you kind of get the hang of it once we do a bunch of these. Steps for solving inequalities, and these are solved, for the most part, they're solved just like equations. We do inverse operations in a very similar way. There's one small exception, except that's when we get into multiplication, and it involves multiplying or dividing by a negative value. It's the number that you're applying inverse operations to. So if you're dividing by negative, or if you're multiplying by negative, you're going to have to do something to the sign, and we'll get to that. All right, so here we go. So let's go ahead and start off on this one. We've got, right here it says graph each inequality, and then we're going to express it in set notation and then interval notation. So here's what we're going to do first. Let's kind of go through these one type of notation at a time. So let's just talk about 1, 2, and 3. Let's talk about 1, 2, and 3 in just how to graph them, okay? So when it comes to graphing these, you can make a number of points on your number line. I always suggest just make sure your number that you're interested in is on there. All right, now this one says x is less than 4. So it doesn't say less than or equal to. So when it's just a less than, or if it's just a greater than, you're going to use an open point, meaning you're just going to put a circle. You're not going to close it up. You're not going to fill it in. All right, so we're just going to put a circle right there, okay? And then we're going to draw our vector. Now, the inequality for this particular problem says less than. X is less than 4. And it's, if you think of that this inequality sign is very much like an arrow that's pointing to the left. So that is telling you which way the vector needs to point. And that vector represents all the values that x can be. Okay, x, and it's a lot, it's an infinite number, but everything that is on this shaded region on that number line is a possible value for x, except 4. 4 is not a value because it's open. It doesn't say equal to 4, it just says x is less than 4. So 3.99, is going to be less than 4, but 4.0, not so much. All right, so that's one way to do it. Another way too, let me just kind of show you this as well. Another way to graph on a number line is to have floating points and floating vectors. Some people prefer this. I really don't mind either way. But you're going to want to have, you can either write it above it or below it. I'm going to do above. And so you can put your floating point right above the 4. And then we're just going to draw an arrow. And the arrow is still considered a vector. And there you go. So that's how you graph that particular inequality. For number 2, we've got W is greater than or equal to. And so when it comes to greater than or equal to or less than or equal to, that is going to be a closed point, representing that that point is also one of the values of W or X or T or whatever the letter is. So we're going to put some points here. And I'm going to put 0 here, 1, 2, put -1, -2. And so for x is greater than or equal to 0, I'm going to put a close point at 0. And then let's look at the inequality sign. Now, notice the inequality sign is greater than or equal to. Also think of it like an arrow. That arrow is pointing to the right. It's pointing to the right. So you are going to draw your vector going to the right, like that. Or shade in your number line that direction. Okay, so right now I'm just talking about how to graph these. Okay, we haven't even talked about set notation yet, and we haven't talked about interval notation. We'll just kind of tackle one thing at a time here. For number 3, what I was just doing is what I usually tell everybody, and this is not a huge deal, but what I would always suggest is getting that t, getting the variable on the other side. I always think it's a good idea to get it listed first. So instead of writing 3 is less than or equal to t, I'm going to write t is greater than or equal to 3. And notice I flipped the sign as well. So that sign flipped around. All right, and then we're ready to graph. All right, now this one says greater than or equal to 3. So we're going to use a close point, and our vector is going to the east. It's going right. It's going up to positive infinity. Now going to the set notation, when you guys do set notation here, we're going to use the brace symbol, right, like that. And this time we're using x. So we're going to put x as all numbers such that x, and then we're just going to basically copy down that inequality right there. So you're going to write down x is less than 4. And that's all you got to do for set notation. For number 2, we're going to do the same thing. We're going to use w though. W is all numbers such that w is greater than or equal to 0. So it's pretty simple to put it in set notation. And then for number 3, we're going to do t is all numbers such that t is greater than or equal to 3. Like that, and that's all there is to it. Okay, now when it comes to interval notation, what we're going to do is we want to look at the inequality. I'm going to zoom in on it. We want to look at the inequality from left to right, because that's exactly how you want to write your interval notation. Okay, now if we look at the left part of the graph of that inequality, that left part is an arrow obviously pointing left, and what that represents is that's going infinitely in that direction, and it's going infinitely negative. So we want to indicate that that's a negative infinity. All right, so when we do this, we're going to write down negative infinity on the left side of our interval notation, and parentheses, always use parentheses when infinity is involved. All right, and then on the right side of our inequality, we got a 4. So that's what we're going to put over here. We're going to put a 4. And then the inequality sign is just less than, and if it's just greater than, you're going to use parentheses. So I know it looks like an ordered pair, like an x and y, but it's not. It's interval notation representing that interval, that inequality in particularly, it goes negative infinity to 4. And the parentheses tell us that it's not equal to. It's just less than 4. All right, for number 2, again, let's look at this from left to right. On the left side, we've got 0, which is a close point. So our interval notation for that one is going to be a bracket. We're going to put 0 there. And then the right side of our inequality represents positive infinity. So you're going to do that. You don't have to put a plus if it's positive, but I'm just doing that just to drive home the point that it's positive. We're going to positive infinite direction. That's what's going on. All right, for number 3, all right, the left side of it represents 3, close point. So we're going to do bracket 3 and then positive infinity. And that's all there is to it. All right, so for number 4, let's kind of go through these a little bit quicker, so I don't have to really go too much into why the notation is the way it is. But for these, all we have to do is just basically solve them, okay? So for number 4, let's just go ahead and add 4 to both sides. Add 4. We're going to solve them just like they are an equation. They're not, they're inequality. So now we're going to rewrite it. M is less than 3. So M is less than 3 right there. And the graph of it, is going to be an open point because it's just less than, and the vector is pointing left because we're talking about all numbers less than 3. The interval notation, or the set notation, let's do that first. The set notation is going to be M is all numbers such that M is less than 3. And then the interval notation is going to be negative infinity. So I used the wrong thing. Parentheses, negative infinity to 3. And then we're going to use parentheses there because it's just less than. If it was less than or equal to, we would use a bracket. We would use that, but it's not. It's just less than, so we do that. That's it. That's all there is to it. All right, for number 5, we're going to divide both sides by 3. Divide both sides by 3, and then you get r is greater than negative 4. Now you might notice something here that we divided by 3, but we divided negative 12 by 3. And you may know kind of in the corner of your brain that when there's a negative involved, sometimes you flip the sign, but not in this instance. In this example, we're not going to flip the sign because what matters most to make that sign flip is what you're dividing by or what you're multiplying by. So the number that we were, make that smaller, but the number that we were applying the inverse operations to each side was positive. We did positive 3. So that sign had to stay put. All right, now graphing it is the easy part now. Just make a bunch of points here. And then we're going to do an open point and negative 4. And our vector is pointing to the left. That's it. Our set notation is going to be R is all numbers such that R is greater than negative 4. And then our interval notation is going to be parentheses, negative 4 is on the left, and then positive infinity is on the right. That's it. All right, number 6, moving on to that one, we're going to divide both sides by negative 3. Now, this is our first example. We're dividing both sides by negative 3. Therefore, we've got to flip that sign. We've got to flip it. So then it becomes R is not greater than, now it's less than negative 4. And it's going to be just like the last one. We're going to do an open point there. Vector is going to the left. All right, number 7, let's go ahead and subtract 2 from both sides. Oh, I forgot something. I forgot the, on number 6, I forgot to do the other types of notation. The set notation for that one is going to be R is all numbers such that R is less than negative 4. And the interval notation is going to be negative infinity, because that's on the left, and negative 4 is on the right, parentheses. All right, now back to number 7. We're going to subtract 2 from both sides. Those go away. And remember, every time you guys do a step in algebra, you rewrite the problem. So now it's negative 2/5 is greater than 10. And then we're going to multiply both sides by 5 to clear that fraction. That's one way to do it. And now we've got, I forgot the x, by the way. Negative 2x is greater than 50. And then we're going to divide both sides by negative 2. And we're dividing by negative. Very important thing to notice here that we're dividing by negative. Therefore, this has got to flip. Because you are taking that negative, essentially you're taking that negative and putting it on the other side. And therefore, that inequality has to remain true. So when we move negatives from one side of an inequality to the other, it mixes things up. So we need to flip that sign along with it. So now it's going to be x is less than negative 25. Okay? Put negative 25 here, negative 24, negative 23. And we're going to do another open point. Seems like we have a lot of open points here. Open point, and it's going to the left. Okay, our set notation is going to be x is all numbers such that x is less than negative 25. There you go. Our interval notation is going to be negative, and keep doing that, parentheses, negative infinity to negative 25, parentheses around both ends. All right, for number 8, right, we're just going to, there's a lot going on in this problem, so we're going to clear parentheses by distributing. Distribute the 2 here, and distribute 2 here as well. There's another way we could do that, by the way. But, hey, you know what? Why don't I just show you? Let's go ahead and do that. One thing that we could, well, let's just distribute. Sorry, I'm going back and forth here. So we got 2 minus 6f plus 4f is less than or equal to 2 times 7 is 14, and then 2 times 2 is 4f. So all I did was clear the parentheses there for the first step. The next step, I'm going to get like terms as much as possible put together on each side. So right here, those are like terms, obviously. And so that is going to make, negative 2f plus 2 is less than or equal to 4f plus 14. Sorry, I changed the order of that a little bit. I just kind of like to put the variable term first. Now I'm going to get variables on the left side. Those cancel each other off. And I'm going to rewrite it again. Now we've got negative 6f plus 2 is less than or equal to 14. And then we're going to subtract 2 from both sides and then divide by negative 6. And we're divided by a negative, therefore this has got to flip. Okay, so you're going to flip that, so now it's going to be f is greater than or equal to negative 2. And we're all finished with that one. And for this one, we're going to put a close point at negative 2, close it, because it's equal to, because we have a little line there underneath it. And then we're going to draw our vector to the right. There you go. On number 9, now this is called a compound inequality. And what you want to do for these is you want to focus on the middle part first. You want to focus on the middle part, and you ultimately want to get the variable by itself. We want h to be the only thing that's in the middle there. So we're just going to apply inverse operations to the plus 3. So the inverse of plus 3 is minus 3. So when we take away 3, there's a couple different sides for this problem. We're going to take it away from the 0, and we're going to take it away from, oops, I did wrong number. Do minus 3 here, and we're going to do minus 3 there. Those cancel off there, and then let's go ahead and rewrite it. So now we have negative 3 is less than or equal to h, which is less than or equal to 2. All right, and so what that means, at this point, you got a compound inequality. What that means is you can look at that a couple different ways. Okay, one way to look at that is, okay, we've got this inequality right there. Negative 3 is less than or equal to h, or h, it's always easier to look at it when the h is first. H is greater than or equal to negative 3. I think that's the preferred way to do it. And then we also have this inequality right here. We have h is less than or equal to 2. Okay, and so now let's go ahead and translate that into our number line, because we want to be able to graph it. And then the first one is h is greater than or equal to negative 3, so we're going to do a close point at negative 3. And the other one says h is less than or equal to 2, so that's going to be a close point at 2. And then your vector isn't necessarily going left to right. We're talking about just the space or the interval in between negative 3 and 2. So that's it. So if we were to write this in set notation, we would write h is all numbers such that h is greater than or equal to negative 3. And we're going to use the word and. Very important to use the word and h is less than 2. So that's how you want to write that. Interval notation is going to be bracket. Negative 3 is on the left. Positive 2 is on the right. And that's it. All right, for number 10, this is a perfect example of why clearing fractions is not a bad idea. So we're going to multiply everything by the LCM, which is 6. So we're going to multiply everything by 6. So I kind of squeeze these in here. Sorry, it gets kind of sloppy. But we're going to do 6 divided by 2, which is 3. That becomes 1. 6 divided by 3, which is 2. 6 divided by 2 is 3. 6 divided by itself is 1. So we're just going to multiply these. Multiply those values that you have right there. So we have negative 3 is less than 4p. 2 times 2 is 4. Plus 9 is less than or equal to 11. All right, now we're going to focus in on that middle part here. Focus in on this part. And we're going to apply inverse operations to that so that we get the f by itself. We want to get that f by itself. So subtract 9 from all sides, not just the left side or the right side, but from all sides. These, of course, cancel out. That's what we want to happen. So now we have negative 12 is less than 4f, which is less than or equal to 2. Divide everything by 4. Divide everything by 4. So when you do that, we get negative 3 is less than f, which is less than or equal to 1/2. And then if we were to graph this, now I'm not going to do this very neatly or to scale in any way, but let's say this is negative 3. Let's say this is 1/2 right here. We'll put those underneath. We've got negative 3, and we got 1/2 right there. And we're going to do an open point at negative 3 because it's just a plain inequality sign. It's less than or greater than. Close point at 1/2 because it's equal to. And then we're going to fill in the vector or the interval that's in between it. So the set notation for this is going to be, what are we using? F. F is all numbers such that f is greater than negative 3. Use the word and. F is less than or equal to 1/2. Close it up. Then our interval notation is going to be parentheses, because on the left side it's just open point, negative 3, and then 1/2 bracket, because it's equal to. All right, for number 11, do the same thing. Let's focus in on that middle part. We want to get x by itself. So let's add 5 to everything. Those cancel off like we want them to. And now we have negative 2 is less than negative 2x, which is less than 8. All right, now we're going to divide everything by negative 2. Everything by negative 2. Everything, right? Those cancel off. Now, since we're dividing everything by negative, the inequality signs are going to flip around. So negative 2 divided by negative 2 is positive 1. I'm going to flip that to greater than. X is now in the middle. Flip to greater than negative 4. And now, since we flipped the sign, everything's backwards. So let's turn this inequality around. Let's put negative 4 on the left. Put less than x, which is less than 1. There you go. And then we're going to do an open point at negative 4 and an open point at 1. And you're going to fill in that vector right there. Okay, now for number 12, this is our first word problem that involves inequalities. And my advice to you guys when it comes to word problems, the wording of inequalities is somewhat confusing, a little bit confusing for some people. But it really just takes a little bit of thought. If you put a little thought into what it really means, then it makes more sense. You know, for instance, this particular problem, I haven't even read the problem yet, but for this particular problem, I'm going to kind of just zero in on it right away. This particular problem says at most 215. Now, at most is an indicator for what kind of inequality we want to use. So at most means less than or equal to. Because think about at most. At most, if you had, you know, at most, at most, I'm trying to think of just any, let's see, at most 5 stars? Well, you could have 3 stars. You can have 4 stars. You can have 5 stars. You can have those, but you can't have 6 because it says at most you have 5. You have 5, but you could have, you could have 4. You can have 3. You can have 2. You can have 1. You can have even 0. But I went ahead and wrote down some of the more common ones there that you're going to see in terms of the wording of an inequality. At most means less than or equal to. At least means greater than or equal to. So you can see with those first two, the wording, and this only applies to like these more complicated inequalities, but the wording is somewhat backwards to what you might think it is or what it does mean. At most, it's got the word most in it, which makes it sound like greater than, but it's actually less than or equal to. At least, you see this right here, at least, it's got, least in it. It sounds like less than, but it's not. It's actually greater than or equal to. If you had at least 5 donuts, that means you had 5 at the very least. You had 5 or 6 or 7 or 8 or 9 or 10 or 11 or 12. You had a lot of donuts. Okay? And then same thing applies to all the rest. No more than, no fewer than, a minimum. A minimum, again, sounds like less than. But if you're driving at a minimum of 30 miles per hour, that means you didn't go less than 30. You went 30 or 31 or 32 or 33. So you went 30 or greater. All right? Or a maximum. If you drove a maximum of 10 miles today, you drove a maximum of 10, well, it means you went 10 or less. So less than or equal to. Now, when this comes to, so I'll let you guys set these up on your own, but I just want to move on from that one, and I'll stop there.